So hello everybody, we are going to do your practice test in Algebra 2, this time with sound, okay? So let's go to work as quick as we can, okay? Actually, I'm going to go ahead and I don't want to do this exact test. I gave you all the answers to this one, right? So what I'm going to do is regenerate this test. I'm going to make a new one. It's pretty much the same. It's the same format, but just different numbers, okay, to make sure you guys really know what's going on. So let's check this out, all right? And really, I really don't want to take forever on this. I don't want to waste your time, okay? So the degree is the highest power of the variable. So our variable in this one is x. And what's the highest power? It's 6. So the degree is, well, I was going to write 6, but let's put the number, okay? Degree 6, okay? And what's the number of terms it has? If it has one term, we call it a monomial. 2 terms is a binomial. 3 terms is a trinomial. But anything more than 3 is just called a polynomial. So in this case, we have 1 term, 2 terms, 3 terms, 4 terms. There's 4 different terms that we're adding and subtracting together. So that means we have this as a polynomial. So we'll just call this a degree 6 polynomial, all right? A degree 6 polynomial. Let's move along, okay? I don't want this to take forever. I want you guys to just see how to do this. So 10x cubed, what's the degree of this one? The degree is 3. And the number of terms in here, again, is a polynomial, all right? Anything more than 3 terms is a polynomial. Here we go. So now for number 3, we're going to simplify this expression by combining like terms, right? So we're going to start with the highest power. That's the most easiest thing to do. So you can also distribute the negative. I have a couple ways of doing this, all right? The way I do it in my head is I say to myself, okay, I'm doing 5a minus 2a. I'm doing negative 6a minus negative. Okay, well, what's minus and negative? All right, let's go through this. So what I'm going to do is just copy this row right here. But now I'm going to distribute this negative to everything in there to make sure that we do exactly what we're supposed to do. So minus negative means plus. And minus negative means plus. So that's the way that worked out, okay? It's almost like if we had a negative 1 that we multiplied times everything, right? Distribute the negative. So if I do negative 6a to the 4th plus 6a to the 4th, they cancel out, right? Do you see that? These two things are definitely going to cancel each other out, okay? So they're gone. Now we know we have 5a minus 2a. That should only leave us with about 3a left over, right? And then if we have plus 3, we should have 6, okay? So there you go. You should have 3a plus 6 for this problem. And just make sure you combine the terms that are the same. And don't forget to distribute your negative to everything so that if it's positive, it turns into a negative. But if it's negative, it turns into a positive. So those are some basics, all right? Right here for this one, I want you guys to FOIL. So in this case, we're going to get 5 times 2 is 10, and m times n is m squared. And then you get 5m times 7 is plus 35m. And then when you get negative 5 times 2m, you got negative 10m. And the last thing is going to be negative 5 times 7, so you get negative 35. All right? Well, we can simplify the 2 middle terms in here, right? We have 35m minus 10m. That equals 25m minus 35. Okay? So just use FOIL for this, okay? Multiply it out. That's all it is. This one should be kind of easy. You should see that you're going to just have 64p squared minus 25, right? This is called the difference of squares. When you have a minus and a plus and everything else is the same, right? We got 8p minus 5 and then 8p plus 5. The numbers are the same. The only difference is that minus and that plus. That means all you really have to do is square the first thing and then square the second thing. And why is that? Well, that's because 8p times 8p is 64p squared, and then 8p times positive 5p makes, well, positive 40p. And then when I go like this, I get negative 40p. And the last one is negative 5 times positive 5 makes a negative 25. Well, I can see these two are going to cancel out. So what do I end up with? 64p squared minus 25, okay? So some of you might have to go through the whole thing before you even notice, oh, this is a difference of squares. Some of you are probably going to be like, hey, it's a difference of squares. Square the first thing, square the second thing, put a minus in between them, and that's the end of the story. So, if you're still stuck, just go keep looking up factoring ones. For this problem, I'm not going to multiply it all out, but I'll show you what to do. You would do 2x minus 3 times 2x minus 3, and then do your FOIL. This times that times that, this times this, and this times that, and combine all your like terms, okay? For number 7, it's a little more complicated than that, okay? Now, this would be a really long thing, okay? We really want to save time, as opposed to writing out 3b plus 1 times 3b plus 1 times 3b plus 1. Isn't this going to take a long time, okay? Well, that was why we studied in class a way that you could do this problem a lot faster by learning Pascal's triangle, okay? So we're not going to do this way. Whatever you do, don't do that, okay? Please. Do that only in like the emergency that you completely forget everything that I'm about to say right now, okay? If you remember this, it'll take you about a quarter of the time it would take to do the long way. So what you have to remember how to do is use these boxes that I'm using. And I know you usually don't use boxes in math, but it's a good way to work right now, okay? So put a box right here, and then we're going to put parentheses for 3b to the 4th power. So take this number right here to that power, and then take the second number to the 0 power, okay? Then put a plus, and then put a box again, right? And then now we're going to put 3b to the 3rd power, and then we're going to bring 1 to the 1st power. So I hope you see that this decreased by 1 power, and that the 1 increased by 1 power, right? So then we get another box, and we get 3b to the 2, and then we get 1 squared, okay? And then we're going to have a couple more terms over here too, right? We're going to get, let's you know what, let's suffer through it and write it all out one more time, okay? I'm sorry I did this, but let's just go ahead and write it all underneath here, okay? So we're going to get a box times 3b to the 4 times 1 to the 0, okay? And then we have plus, and we have a box, and we have 3b to the 3, and then we got 1 to the 1. Then you have a plus and a box, and then you have 3b to the 2 times 1 to the 2. And you have a plus, and then we get our box, and then you get 3b to the 3 times 1 to the 3, and it looks like we missed some space, right? So we're going to have 3b to the 4th times, excuse me for this, times 1 to the 0, okay? So, oh, my fault. I mean the other way around. This is to the 0, and that's to the 4th, all right? So, what numbers go in these boxes now, okay? You know what? This is way too weird looking. I'm sorry about this, man, but the starboard is kind of tricky sometimes with the spacing, so. Okay? And plus it's a power of 4, so just let me clean this up a little bit. I'm sorry that looks so messy. So you could just fast forward to that part of me copying this over, right? Because you guys are watching this on your computer. 3b to the 2 times 1 to the 2 times 1 to the, oh, my fault. Well, this should be decreasing every time, right? So this needs to be 1. And now we get 1 to the 3. And so now we're at the last term, right? We get 3b to the 0. And now we finally fit everything. I'm sorry, so please get up to this part. I'm sorry that you had to sit through that in the video, but at least you can fast forward to erase it, okay? Or to save your time. So our Pascal's triangle starts off like this. There's 1s on the outside, but to get the inside numbers, you have to add the last 2 on top of it, right? So 1 plus 2 makes 3, and 1 plus 2 makes 3. So we need to have, we have 5 boxes, 1, 2, 3, 4, 5. And we need to put 5 numbers in them. So don't put the numbers from this row because there's only 4 of them. You have to go one more step, okay? So 3 plus 1 is 4, 3 plus 3 is 6, and 3 plus 1 is 4. So the numbers that go in here are the ones that come from the row that has 5 numbers, okay? So we're going to use this row right here. So we're going to put 1 in there, we're going to put 4 in here, 6, 4, and 1, okay? And then we're just going to use those numbers as coefficients. The only reason I had them in boxes was just to make them stand out. You could use parentheses too, okay? I just didn't want there to be excess of parentheses that would really kind of make it look more confusing maybe, okay? I want you guys to think that it's just a number in a box, okay? Just put it right there. So now we're going to kind of reconcile all of our coefficients and just multiply them all out, right? So we got 1 to the 0 is 1, and 1 times 1 is 1. So when we do 3b to the 4th, we have 3 to the 4th and b to the 4th. So 3 to the 4th is actually 81. So you guys can test me on that. We'll figure out why 3 to the 4th is 81. And over here, we're going to have 1 to the 1 is 1, and 1 times 4 is 4. So now we have to do 4 times 3 to the 3. And 3 to the 3 is going to be 27. So 4 times 27 makes 80 plus 28. That's 108. So we have 108 b cubed, okay? So don't forget to just get 3b cubed. That's 3b times 3b. So, I mean, just do what you have to do, all right? It's going to be a little bit of multiplying, right? So now we have 1 squared, that's just 1, and 1 times 6 is 6, so we're going to have 6 times 3b squared, and 3b squared is 9b squared, right? So we got 9 times 6, and then times b squared, and 9 times 6 is 54, so we have 54 b squared, all right? And then we're going to come over here and put plus, and we see 3b to the 1 is just 3b, and 3b times 1 cubed, well, 1 cubed is just 1, so it doesn't change. We have 3b still. And 3b times 4 is 12b. So at the last one now, right? Anything to the 0 power is 1. So really we have 1 times 1 times 1 to the 4th, but 1 to the 4th is 1. So we have 1 times 1 times 1. And 1 times 1 times 1 times 1 is 1. Alright? So I'm sorry for some reason my writing started slanting, but there you go. Alright? You have your answer for this one. It's completely expanded. And we took a little less time than it would have taken to multiply it all out the long way, even though I had to recopy this twice, okay? Sorry about that, by the way. So, have fun practicing those. I think I have a video on those, I'm not sure, alright? Let's try this one real fast, okay? So we're going to do our box, and then y to the 3rd, and then 2 to the 0. Then plus in your box, and then y to the 2nd, and 2 to the 1. Then your box, and then y to the 1, and 2 to the 2. And then you got your box, and then you got y to the 0, but now 2 to the 3. And since we know we're going to put 4 numbers in there, you got your 1, your 1, your 1, 2, 1, and then you have your 1, 3, 3, 1. So it's going to be this row that we put in, right? 1, 3, 3, 1, okay? Sorry my boxes aren't so square. So now, 2 to the 0 is 1, and 1 times 1 is 1. 1 times y cubed is just y cubed. And then 2 to the 1 is 2. 2 times 3 is 6. So this makes 6y squared. Then we get 2 squared is 4. And 4 times 3 makes 12. 12 times y is just 12y. And then now we have 1 times y to the 0, which is 1. Anything to the 0 is 1, right? So we get 1 times 1, that's 1. And 1 times 2 cubed, well, 2 cubed is 8, and 1 times 8 is just 8. So there is our other problem, and this is our Pascal's triangle that we use to get the numbers that go in those boxes that we did at the beginning, all right? If you rewind this a couple of times and you don't get it, you might find yourself getting a little more familiar with it, okay? So just practice. So factoring this problem right here goes like this, okay? You're going to factor the right side, and then you're going to factor the left side, okay? Or you can factor the left side and the right side. I'm actually going to start on the left this time. So I'm going to pull out an x squared, all right? Because I see this is 3 times x times x times x, okay? And this is 3 times 4 times x times x times x. So the only things that are common is this 3, and then, well, this has, actually, this is only x squared, right? So there's not 3, there's only 2 of them, right? So there's 2 in common, and there's 2 in common. So I could factor out a 3x times x. That's 3x squared. So I'll take out a 3x squared, and what has to stay in is the things we didn't take. We didn't take a 3 right here, right? And we didn't take that x. So the 3x, and then you can double check. Is 3x squared times 3x equal to 9x cubed? 3 times 3 is 9, and x squared times x is x cubed, so we're okay. And then we see in here we're going to have 4 is going to be the only thing that stays, okay? 4 times 3x squared is 12x squared. So now over here we're going to try to factor out a 2. That's the only thing I see that's common to both of these terms. So we'll put a plus right in there, we'll take out a 2, and then what I see inside is 3x times 2 is 6x, right? And then this needs to be minus 4. Because 2 times 4 makes 8. So the problem is not so hard. At this point, all you have to do is copy the thing that repeated itself right now. You copy this 3x minus 4, and then copy that right there, 3x squared, and then go ahead and put the plus 2 right here. Okay? So what we did is we put this right there, I hope you see. And we copied the 3x squared in there, and then this binomial just happens to be the one that repeats. So you copy the one that repeats, and then make a new binomial made up of the term that's the coefficient of that binomial plus the coefficient of this binomial. Alright? So good luck on the factoring by grouping on those ones. If you need more help, just look up factoring by grouping, and you can you'll probably see plenty of videos on the internet about this. But we got a whole test that's a little bit more than just factoring. So if you want to try this one, let's do this together, alright? Factor this side and factor that side. I already see that I have to pull out a 7. That's big enough, and I have to pull out an r squared. So in here is 4r minus 7. And then I see here, well, the only thing I could factor out is probably a 5. So this is going to be 4r, and then I got to multiply this times negative 7 if I want to get minus 35, right? So like I said, in here, you're going to put the one that copied itself, that repeated itself twice. We have 4r minus 7 times 4r minus 7. So just write that in here. Then we're going to copy the first thing we wrote, 7r squared, and then you put the plus 5. Alright? That's just the order I like to go in, alright? That's the way you're going to do these problems. Factoring by grouping, like I said, if you are stuck, definitely look up factoring by grouping, okay? Because these problems aren't that hard, but they just take some kind of backwards thinking. So I don't blame you if you're a little confused, but if you watch a video on factoring by grouping, you might be able to get this on your own. So right here we have the sum of cubes. And for the sum of cubes, our formula is, we know that x cubed plus y cubed equals x plus y times x squared minus xy plus y squared. Okay? So we're trying to find out, what you have to do to write this is you need to really write this in the form of two things that are getting cubed. So we have our x getting cubed, but what number do I cube to get 8? 2. 2 cubed is 8. So now we've wrote this in a form like this, and they kind of match up. So now we can use our formula pretty easy, okay? What it means by x is, it means what number are you cubing, right? The number I'm cubing here is x. I'm cubing x, right? So that's why we have an x in this polynomial over here. Well, if I'm cubing 2, then that means I put a 2 here in front. And since I'm cubing x next, we put a plus x, alright? So now, we're going to look at the first term, x squared. Or what is our x? Our x is 2. So what's 2 squared? That's 4. And then you do a minus. And then multiply these two things together. That's what x times y means. It means multiply these two numbers. Not after they're cubed, but just multiply those two together, okay? So 2 times x is just 2x. And now you put a plus, and then we need to get y squared, and by y they mean, what is the second thing you're cubing? The second thing I was cubing is x, so I just put x squared. And that's the end, alright? That's called the sum of cubes. If you need more help on this, please research a video on sum of cubes and look at it, and you'll be able to see something that focuses on sum of cubes. But like I said, I don't want this video to run forever. I want you guys to actually just kind of use this to refresh your memory. So let's go ahead and move along. Alright guys, that was sum of cubes. Well, it looks like we have another sum of cubes, so I'd rather not do this one. Alright, we'll jump over. So in this case, we have a m to the 4th minus 1. And they didn't give us something so nice here. I'm going to skip this one, okay? I don't know where that problem even came from. So here we go. I want to give you guys a problem for this one that's a little different than the one that got automatically generated. So let me change this problem. And I'm looking for all whole numbers so we don't get too confused. And let me give you an honest difference of cubes, okay? So that we don't end up, oh, that's what it was. Oh, sorry. That's all right, cool. I was trying to figure out why that was coming out that way. I thought that was going to be a sum of cubes, but actually it was a quadratic form. So we'll do this real quick. All right, sorry, guys. So quadratic forms like this one, that's x4, and this has a 2. And there's no x cubes, and there's not even an x in here. So really, you have to recognize that this is going to be something like x squared times x squared. And we have to put, some numbers in there like when we did our regular diamond problems even. So we need 2 numbers that multiply up to 90, but that add up to 1. Because there's an invisible 1 right there, right? So what numbers can we multiply up to 90, to negative 90, and they add up to 1? So we got negative 9 and positive 10, right? If I multiply them, I get, do I get negative? Do I get positive 90? Yeah, I get negative 90 when I multiply them, and when I add them up, I get positive 1. So these are the right numbers. So since these both say x squared, it doesn't matter which one goes where. And there you go. Okay, it's just like the old diamond problems you did in Algebra 1, just with the x squared instead of an x. So now let's look at this polynomial function of least degree thing. Okay, we're going to write a polynomial function that has these zeros. Okay, so what you need to know is the factor thing. If the number a is a 0, all right, and I kind of want to write this a in blue because if a is a 0, then x minus a, put that in red, is a factor of our polynomial, okay? So if a is a 0 of the polynomial, then x minus a is a factor of the polynomial. That's the part I'm taking out so it doesn't get too wordy. So if 1 is a 0, right, this is a 0. So that means that x minus 1 is a factor. And if negative 2 is a 0, that means x minus negative 2 is a factor. And if negative 1 is a 0, that means x minus negative 1 is also a factor. So if we go ahead and simplify this, minus a negative means plus, and minus a negative means plus, right? All you have to do now is multiply this together, and you'll get the answer. And we can change the order around a little bit to make this easier. I'm going to multiply these two together so we get difference of squares real fast. So x minus 1 times x plus 1, and then we'll multiply it times this one last, okay? And multiplication doesn't matter what order you do it in, right? 2 times 3 times 4 is the same thing as 4 times 3 times 2. So all I did is change the order around, right? So you should see this is difference of squares right here, right? What are we going to get? We're going to get x squared minus 1. And that's it. It's over. All right. This is difference of squares. You square the first thing, then you put a minus, then you square the second thing. But 1 squared is 1, so that's why it happens so fast. And now we're going to put x plus 2 over here and distribute. So x squared times x is x cubed, and x squared times 2 is 2x squared. 1 times x is minus x, and negative 1 times positive 2 is negative 2. So this is the full answer right there. That's how you multiply it all out and get the last answer. Alright? So it really all hinges on you knowing this already, the factor theorem. And I made a whole video on the factor theorem, so if you do not understand the factor theorem, go ahead and look at my YouTube channel and check out the factor theorem video. It's a little longer than the section I'm going to be able to do on the practice test, okay? So, that's our factor theorem review. Let's move along a little bit. Well, now you got to divide for this one. And honestly, I already have talked about synthetic division, so instead of just showing you how to do this in this video, I'm going to direct you to the synthetic division video, okay, because there's way more problems in that one, and if I just do one problem here, all it's probably going to do is make this video really long, alright? So please look up synthetic division on my ACME Red Devils channel, right? ACME Red Devils, alright? Just go ahead and type that in. Look for synthetic division on my channel, and you'll be able to find a video that shows you how to do this problem, okay? So I'll move to the next one. Factor each one root has been given. These problems are kind of long, and I think I might do this one by hand and upload it as part 2. So this is probably going to be the end of... let's do rational zeros, and I'll do that one for the last. All right, so... we have to know P is a factor of -1, okay? And Q is a factor of that number, 2, okay? So P is a factor of 1 and Q is a factor of 2. So we're going to go ahead and just put those numbers where they go. I just wanted to show you guys where they come from, okay? So now you have to know P comes from the first digit, and Q comes from, P comes from the last digit. Q comes from the first coefficient, okay? So now we have to write our possible rational zeros of P over Q. Okay? So I'm going to ask you, how many different factors of 2 are there? Well, we know there's plus and minus 1 times plus or minus 2, and then that's it. There's nothing else. And there's only one factor of 1, basically, is plus or minus 1. And there's nothing else. So the only numbers that we can divide for P over Q, we're only going to have 2 different denominators. One of our denominators can be plus or minus 1, and our only other denominator can be plus or minus 2. It also happens that there's nothing else that we can have for our numerator. Plus or minus 1 is the only thing that can go on top, because we don't have any other choices for P. So this has to be plus or minus 1. And if we simplify this a little bit, okay, we'll see that plus or minus 1 over 1 is plus or minus 1. And you can just kind of simplify this into just one number. And plus or minus 1 over plus or minus 2, it means exactly the same thing as plus or minus 1/2. Alright? So, there you go. Those are your answers. I'll fix that bracket just because I don't like it right now. So, that's your answer. Then you would plug in these numbers into the polynomial and see which ones give you 0 after you plug in 1 or -1 or 1/2 or -1/2, okay? And that's going to be the way you solve this whole problem. So the end behavior of this function is, as x goes into infinity, f of x approaches blank, and as x goes to negative infinity, as x approaches negative infinity, f of x approaches what? Fix this arrow. Fix both of those arrows. And the infinity I messed up. Alright, so I hope you guys can see these are arrows. Alright, so that's as x approaches infinity, f of x approaches what? Well, let's think about it. if you cube a positive number, like if you cube 2, 2 cubed is 8. And then what's 5 cubed? 5 cubed is 125. So if we cube numbers that get bigger and bigger, our function is just going to blow up. It's going to go more and more positive. So as x approaches infinity, since these numbers stay positive, we're going towards positive infinity. So something you should also notice is that if you have an odd degree to your polynomial, the end behavior has to be different at the end. So we already know, since that goes towards infinity, this is going to be negative infinity. But let's talk ourselves through it first, okay? Let's see why this makes sense. Well, if I cube negative 2, that means negative 2 times negative 2 times negative 2. Well, negative 2 times negative 2 makes positive 4, right? But positive 4 times negative 2 makes negative 8. So I hope you see that if you cube any negative number, only 2 of the negatives will cancel out, but another one's still going to be hanging out there. So your number is going to be negative at the end no matter what. So what does that mean? If we put numbers that are negative, we're going to make sure our numbers become negative after that, right? So this justifies why we're going towards negative infinity, okay? Because our numbers are always going to be negative. They have to be negative if you cube a negative number, all right? So good luck with that. It's all about looking at the sign as you do this leading coefficient. All you really have to look at is this. You don't have to look at anything else in the polynomial. Just look at the first leading, the variable with the highest power, and that's going to tell you how it acts. So, last one. All right, guys. I really am not going to calculate all the values real quick. I'm going to go ahead and we're just going to click the answer. Okay? So, if you guys would press pause and try to do this problem, we can have a couple of answers shown on the board real fast. So, go ahead, try to do this for yourself and see if you get it right. And then press pause. And now that you're back, let's see if you got it. So, we could see that we would have calculated that negative 1 gave us 2, 0 gives us 4, and if we plug in 1, you get 4 also. And then we probably would have seen that our other two numbers take us off of the graph, so you would have to know that it's going to pass through every single point, right? So good luck with those problems. If you want to see another one, I want to do another one now that I showed you the answer at the beginning. So it's going to be the last problem I do on this right here, I think, guys. Bam. Alright, here we go. So go ahead and press pause and try to graph this for yourself right now, please. And I'm going to show you if you got it right or not. So let's move the graph a little bigger. And I guess you can see that 8 is at the bottom, so just forgive me for cutting it off a little bit. I want to zoom in on the graph so you can see that better. And this is the graph you should have, okay? So good luck to figuring out what's going on these graphs and factoring problems. And I just want to let you know that I'm going to add a new video just on this. And I'm going to do it by hand because it gets kind of big on the starboard and everything, all right? Good luck, guys. Have fun studying.